Hi, I am Dr. Harikrishna Mulam, Associate Professor, Department of EIE. In this lecture, we will solve a problem on time response analysis. So, let us solve this problem. Here, we need to obtain the response of unity feedback system whose open loop transfer function is g of s is equal to 4 by s into s plus 5, and when the input is unit step input. If you see, the information that is given here is you need to find the response of the system. So in case of control systems, the response means output, and output is represented as C of t in control systems in time domain. So obtain the response of the system. You need to find response output of the system, which is C of t of a unity feedback system. So in case of control system, we know that the feedback transfer function is represented as h of s, and as the feedback is unity, this h of s is 1. And in this system, the feedback is unity, and the open loop transfer function of the system is g of s is equal to 4 by s into s plus 5. So open loop transfer function g of s is equal to 4 by s into s plus 5. And the other information that is given in this problem is the input is a unit step input. The input in case of control systems, we write it as R of t. R of t is equal to unit step input. Mathematically, it is written as 1. Okay. So the h of s, g of s and R of t is the information that is given in this problem, and you need to find this C of t. Okay. Then C of t is the output in time domain, whereas C of s is the output in Laplace domain. Here the information that is given, feedback transfer function, open loop transfer function, they are in S domain. So first of all, you need to find the output in S domain. After that, take the inverse Laplace transform to get the output in time domain. So this is what you need to find, and this is the information that is given to us. Therefore, in order to find the C of S first, actually we know that the transfer function of a system, see here we are saying that it is a feedback system. So it is a closed loop system. Whether it is closed loop or open loop, whatever may be the type of the system, transfer function is represented as Laplace transform of output to that of the Laplace transform of input. So T of transfer function TF is equal to C of S, Laplace transform of output, by Laplace transform of input. So we need to find C of S, and we need R of S, and this transfer function of a closed loop transfer function in terms of open loop transfer function and feedback transfer function is given by the formula G of S by 1 plus G of S H of S. Okay. So in this expression we need R of S also. Therefore R of t we know it is equal to 1. Therefore R of S is Laplace transform of R of t. That is Laplace transform of 1 is equal to 1 by S. Okay. Now from this expression, okay, you can write C of S is equal to G of S by 1 plus G of S H of S into R of S. Therefore, C of S is equal to G of S is 4 by s into s plus 5. So if you multiply, it is s square plus 5s whole divided by 1 plus g of s is 4 by s square plus 5s into h of s is unity into r of s is 1 by s. That is equal to 4 by s square plus 5s whole divided by, if you consider the denominator here and the denominator of denominator is s square plus 5s, whereas the numerator of the denominator becomes s square plus 5s plus 4 into 1 by s. Okay, so the denominator of numerator and the denominator of denominator gets cancelled. Therefore, output in s domain c of s is equal to 4 by s square plus 5s plus 4 into 1 by s. So this is the output in s domain, but you need to find the output in time domain c of t. So if at all you want c of t, you need to take inverse Laplace transform of c of s. That is equal to inverse Laplace transform of c of s is 4 by s square plus 5s plus 4 into 1 by s. But we don't have any direct formula for finding the inverse Laplace transform of this expression. Therefore, before taking inverse Laplace transform, you need to do partial fractions for this c of s. Therefore, c of s is equal to 4 by s square plus 5s plus 4 into 1 by s. If you do, that is equal to 4 by the factors for this s square plus 5s plus 4 is, we know it is simple, s plus 1 into s plus 4. If there is any doubt, s into s is s square plus 1s plus 4s 5s and 1 into 4 is 4. And this, yes. And as per the partial fractions, this can be written as a by some s plus b by s plus 1 plus c by s plus 4. If at all you have any doubt or if you don't know about partial fractions, please learn it. Okay, so this expression can be written in the partial fraction form like this, because all these factors, okay, all the poles of this expression are distinct. S is equal to 0 is one pole, s is equal to minus 1 is another pole, s is equal to minus 4 is one more pole. So you can write the partial fractions in this manner. Now you need to find ABC values. So I am not discussing any partial fractions here. So if you have any doubt, you just refer some mathematical textbook, okay, to learn it. So A is, in order to find A, the expression will be like this. The original expression is c of s into, and a by s, therefore this s need to be considered. So here s should be written, and for this s term, the s is equal to 0, that is the root. Therefore, a can be found from c of s into s when s is equal to 0. Therefore, what is c of s? C of s is 4 by s plus 1 into s plus 4 into s whole into c of s into s. Therefore, s when s is equal to 0. This s gets cancelled. Therefore, 4 by S is 0 now. S is 0. So 0 plus 1 is 1 into 0 plus 4 is 4. So 4 gets cancelled. Therefore A will be 1. A will be 1. Okay. Similarly, the expression for B is equal to, if you want to find B, again C of S into, as B by S plus 1 undi kabatti, here C of S into S plus 1, and when for this factor the root is S is equal to minus 1. That is equal to C of S is 4 by S plus 1 into S plus 4 into S into this S plus 1, when S is equal to minus 1. This S plus 1 gets cancelled. That is equal to 4 by S plus 1. S is minus 1. Minus 1 plus 4 is 3 into S is equal to minus 1. Therefore, this is a minus 4 by 3. Minus 4 by 3. Right? Next, we need to find the value for C as well. So, okay. So, in order to find C, you need to consider this S plus 4 now. Okay. Now, C is equal to C of S into S plus 4, and the root for S plus 4 is S is equal to minus 4. Therefore, C of S is 4 by S plus 1 into S plus 4 into S into S plus 4, when S is equal to minus 4. Therefore, S plus 4 gets cancelled. 4 by S plus 1, where S is minus 4. So, minus 4 plus 1 is minus 3 into S is minus 4. Therefore, minus becomes plus. Then 4 gets cancelled. Therefore, C value is 1 by 3. So, like that, you need to find all the A, B, C values that are there in the partial fraction expression. So, now we can write C of S is equal to, what are the partial fraction expression there? A by S. A, you got the value as 1. So, 1 by S plus B. What is the value for B? B, you got it as minus 4 by 3. So, minus 4 by 3 is the B value divided by S plus 1. Therefore, 1 by S plus 1 plus C is 1 by 3 divided by 1 by S plus 4. So, 1 by S plus 4. So, this is the expression for C of S. Now, finally, we need to find the output, that is the response of the system in time domain. The response of the system in time domain C of t can be obtained by taking inverse Laplace transform of C of S. Okay, and we know that inverse Laplace transform of 1 by S. Okay, let me write the formulas here. Inverse Laplace transform of 1 by S is equal to 1. These are all the standard formulas that you should know. So, inverse Laplace transform of 1 by S is 1 minus 4 by 3 is a constant. You need to get the expression for the inverse Laplace transform of 1 by S plus 1. There is a formula, okay, that is inverse Laplace transform of 1 by S plus A is equal to e power minus at. As per that formula, you can write here inverse Laplace transform of 1 by S plus 1 can be written as e power, in place of a, 1 is there. Therefore, e power minus a is 1 into t e power minus t plus 1 by 3. You can use the same formula, inverse Laplace transform of 1 by s plus 4. Here in place of a, 4 is there. Therefore, inverse Laplace transform of it is e power minus 4t. So, this is C of t, which is the response of the system. Response of the system that is mentioned in this problem. Okay. So, we have found the response of the system. Actually, as per this problem, we have completed the problem. But I wanted to just mention few more things. Here, if you remember, we got the transfer function as C. C of s is equal to, otherwise, transfer function is equal to g of s by 1 plus g of s h of s. Okay, and that 1 plus g of s h of s, the expression is this 4 by s square plus 5s plus 4. Okay, 4 by s square plus 5s plus 4. That is the transfer function of this closed loop system. Okay, so let me take that. So the transfer function of this closed loop system, closed loop transfer function is 4 by s square plus 5s plus 4. Okay. Though we have completed the problem as per the problem statement that is given, just I wanted to discuss one or two points. Okay. If at all you wanted to know the undamped natural frequency of the system or the damping ratio of the system, always compare the closed loop transfer function with the formula for closed loop transfer function of the standard system. That is omega n square by s square plus 2 zeta omega n s plus omega n square. Okay. I repeat, if you want to find the damping ratio zeta of the system or the undamped natural frequency omega n of the system, okay, compare the standard way of representing the closed loop transfer function of second order system with the second order closed loop transfer function that you come across in the problem. So if you compare these two expressions, always give preference in comparing the denominator of the closed loop transfer function with the denominator of the standard way of representing the closed loop transfer function. So if you compare s square plus 5s plus 4 with s square plus 2 zeta omega ns plus omega n square, you can write omega n square is equal to 4. Therefore, omega n is equal to square root of 4, which is equal to 2 radians per second. This is the undamped natural frequency of the system. Natural frequency of the system. Then, if you compare this 2 zeta omega n s with 5s, we can write 2 zeta omega n is equal to 5. Therefore, zeta is equal to 5 by 2 omega n. That is equal to 5 by 2 into 2. That is 5 by 4, which is greater than this value. 5 by 4 is greater than 1. So, the damping ratio is greater than 1. It is greater than 1. Therefore, you can say that this system is over-damped system. We know that there are 4 types of second order systems: undamped system, underdamped system, critically damped system, overdamped system. And we know that if the zeta value is greater than 1, then you call the system as overdamped system. This way you can understand by what type of second order system it is. The other way is that closed loop transfer function is equal to 4 by s square plus 5s plus 4. And if you write the factors for the denominator polynomial, it is s plus 1 into s plus 4. Okay? And we know that the roots of the denominator polynomial, that is s square plus 5s plus 4, the roots of that denominator polynomial, from this expression you can write s is equal to minus 1 and minus 4. The roots of the denominator polynomial are also called as poles of the system. Poles of the system. And we have already discussed in the previous classes that if poles of a second order system are real, this minus 1 and minus 4 are real, and distinct, they are not same. Minus 1 is one pole and minus 4 is another pole. Okay, so if the poles of a system are real and not equal, not same, then the system is called as overdamped second order system. So this is what I wanted to discuss in this lecture. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.